Visit github.com, search for simple 61850 modbus, download the zip package to get our 61850 technical data package. After downloading, locate and open FlexLua 61850exe in the folder where the tool software is located. Now, let's explain how to use the tool software to create the configuration files required for the protocol converter to operate. We will creating a simple temperature and humidity sensor. As an example, first, clear the preloaded demo project from the software. Then create a model. Create a temperature and humidity sensor model, named TempHumi, and set its type to YCRC telemetry. Add 3 data points named temperature, humidity, and runtime, with types float, and int respectively. After creating the device model, we can use it to create a temperature and humidity sensor device instance. Assign a serial number prefix and the model name to the instance. Combining the two will form the device instance's name. If you want the 61850 master software to see the name of each data point, you can check DOI. This will create a DAI instance name for each data point. Next, configure the parameters related to RS485 modbus communication. Set the RS485 communication parameters, baud rate, parity, and stop bits. Since this is a data acquisition device, the modbus function code can be set to 03 or 04. Set the modbus address to 1. The wait time and package time are generally left at their default values 1000 and 100. Next, configure the properties of these 3 data points. The register addresses of the 3 data points can be specified in decimal or hexadecimal. For temperature and humidity, select SAB 16-bit signed integer type, since a scaling factor of 0.1 is needed. Set the number of decimal places to 1. For runtime, select UAB 16-bit unsigned integer type, and set the number of decimal places to 0. If you want to include each data point in the dataset and enable automatic data reporting to the master station, check the Report option. Click the Save button. In this way, we have successfully created a temperature and humidity device instance. If you need to add multiple identical device instances, you can use the Copy button to simplify the process. Just remember to assign a new prefix number A and a unique modbus address for each device. Next, configure the parameters related to 61850 Ethernet communication, such as MAC address, IP address, subnet mask, and gateway address, etc. It's important to note that if the MAC address is set to all zeros, the system will use the globally unique ID of the network interface chip instead. The 61850 port number is generally fixed at 102. Setting the keep-alive time to 60 seconds allows the protocol converter to detect a TCP disconnection within 601 to 0 seconds, preventing the TCP connection from remaining in a dead state. Finally, you can also customize the IED name that the master station can see. It's recommended to keep it within 8 letters. Remember that when we created the device instance earlier, we checked report for each of the 3 data points. Now here, you can configure the main switch for the telemetry reporting function and select the reporting mode, either periodic reporting or report on change. Typically, telemetry uses periodic reporting. Similarly, the main switch for status digital signal reporting can also be configured. Since this example does not use the status signal function, we will skip it here. Next, set the polling interval for all RS485 devices to 5000 milliseconds 5 seconds. If you need to configure the SNTP service, you can check this option here. Enter the IP address and port number of the SNTP server, and set the time retrieval interval to 60 seconds. The NetAuto-Fix Network Auto Recovery feature is generally disabled by default, unless the 61850 master station can ensure that it sends at least one read or write command within 7,200 seconds. Finally, click the Generate File button. Place the generated main, Lua, and model, CFG files into the protocol converter, and provide the R2 SID file to the master station developers for device import. We can find the 3 files mentioned earlier in the output folder. Next, connect the protocol converter to the computer using a USB-C data cable. Then drag the newly generated main, Lua, and model CFG files into the protocol converter's 1.4 MB USB drive to complete the entire configuration process. After disconnecting the USB-C cable and powering the protocol converter with 12 volts, it will collect data from the RS485 temperature and humidity sensor, according to the main Lua file, and report the data to the 61850 master station every 3 seconds, according to the model CFG file.